Hello there. Welcome to School of Statistics at Statistica Hub. So this will be a course on stochastic process, level 1. So this will be an introductory course. As you can see, the level is only 1. And you will get a basic idea like what is the meaning of stochastic process and all the terms that are related to this particular things. Well, so some brief intro about me. So my name is Rahul and I'm the course instructor for this particular course. And I'm the founder of Statistica Hub, that is an e-learning platform at global level. In my educational background, you may find that I am having a bachelor's degree in statistics from Ramjas College, Delhi University, and a master's in statistics from IIT Kanpur, India. Well, so I'm like a commercially full-time teacher, and in that particular setup, in the last 1 year, technically in the batch of 2023 to 24, I had delivered roughly 40 plus different courses at different level, university level students. So that was some brief intro about me. Now let's start with the particular topic that we have to cover today. In this particular lecture, I will go through the basic review about probability. Because to understand the stochastic process, you must be having an idea what is the meaning of probability, random variable, distributions, and all that. So this will be the first lecture, and we have to go through the introduction or some sort of like review about the probability theory. Well, so let's start. So the first topic that we have in here is probability review. So I hope everyone have a basic idea what is the meaning of probability. So if I just simply say probability, so what does probability mean to say? So probability. So in the very basic or the layman language, we can simply say probability mean to say chance of occurrence of something, right? Chance of occurrence of something. Now, what is this chance basically mean to say? So if I just basically give an example, maybe the coin tossing example. In this one, you are having some possible outcome. There can be a head, there can be a tail. That kind of thing is there. Now, we can have another example. Let's say some ceiling fan. So if you have the ceiling fan, then again, there are two possibilities. It can fall down or it may not fall down. So you can see these are two different experiments and both are having different type of scenario. So if you think about the first case that appear to be like appropriate, like if you toss up the coin, there are possibilities and you may be getting a head, you may be getting a tail. But if you go for the second case, then there is very less probable that the fan will be falling down, right? The basic idea about the probabilistic terms. Well, in that particular case, you must have covered some particular thing that probability of any event A, that will be number of elements in that event over total number of element, right? The most generic or most basic form that we cover in the probability. So let's try to understand this in a much more detailed manner. How do we deal with probability? What is the meaning of like probability and how the probability is like introduced in statistical terms? That will be our aim in this particular lecture. Well, so the first term that you have to understand that is known as experiment. So what's an experiment? Most simple form will be like experiment mean to say like you perform anything. Like if you read something, maybe you are following some particular book. So that is some sort of experiment we can consider. You may be able to understand the concept from the book or you may not be able to understand the concept, right? Okay, assume that you are working on your degrees, maybe some bachelor's or the master's degree. So you may be having some particular aim, but okay, by reading this particular degree, I will be getting this particular kind of job maybe. Now, again, in the real world scenario, it is not like 100% secure that you're going to get the particular job, right? Because there is a lot of unemployment and everything. So maybe the experiment, like studying something in a hope that you may be getting a job. So there can be some different possibility also. Okay, maybe my example appear to be not so decent, but yeah, that is some sort of experiment. Okay, so experiment basically mean to say an action that is performed to observe some outcome. Outcome can simply say some sort of like result in most simple form. Okay, that is any kind of experiment that you can consider. Okay, but in the context of probability, in the context of like statistical learning or statistical analysis, anything that you do in statistics, we have to consider not only the experiment, but there is a term that is known as random experiment. So that is something that you have to understand. What is the meaning of a random experiment? So what's a random experiment? So actually the complete statistics that is depending on this word random. Now, this random doesn't mean that it will be like very, very random, that I'm studying this particular degree in mathematics or statistics and I'm having a deep knowledge of chemistry, like after this particular course. No, that is not possible because I'm not teaching you something that is like related to some other course. This is typically a statistical course, so you will be attaining some knowledge in the course only. So at the end of the course, there are two possibilities. You may be getting the knowledge or you may not be getting the knowledge, whatever I'm going to deliver, right? I'm not saying that whatever I'm going to teach, you will get like everything, but there is a possibility that you may attain a knowledge or you may not attain a knowledge, that kind of thing. Okay, so that means to say a random experiment is an experiment with at least two outcomes, with at least two outcomes that are predefined. What does predefined mean to say? So predefined basically mean to say before the experiment, you know what can be the possible outcome. Yeah, the basic term. So the experiment with at least two possible outcomes that are predefined. So that means to say, if I just go for the coin tossing example. So before the experiment, you know, there can be a head, there can be a tail. It is not happening that you are tossing up the coin and maybe some animal is coming up. No, that is not happening, right? So that kind of thing is there. So you know what can be the possible outcome. Okay, that is like half definition. If you move ahead, so experiment with at least two outcomes that are predefined, but we are not sure about the we are not sure about the final outcome. Okay, got this basic idea, final outcome, and I can add up one more word, final outcome in a particular trial. So if you perform the experiment for any particular time, then you are not sure whether it will be a head or a tail. But before the experiment, you know it can be a head or a tail. So this final outcome that we have, that is holding up the concept of randomness. And there comes the concept of like probability, chance of occurrence of something, uncertainty in something, that particular kind of thing. So that is the idea of a random experiment. So we define something that is known as sample space. So what's a sample space? So in most simple form, sample space is a set of all the possible outcomes, set of all the possible outcomes of a random experiment. Okay, you perform the experiment, there can be multiple possible outcomes. If you perform or if you set up one set of those possible outcomes, then that is considered to be your sample space. Moving ahead, then we have something that is known as event. So event is just a subset of the sample space. Okay. Now, if I just define basic terms, so probability of any event that was coming out to be NA over NS. So under this one, the first thing we have to understand is equally likely events. So what are equally likely events? So events that are having the same chance of occurrence, that type of things. So events having same chance of occurrence. Okay, that particular thing. So those type of events. So if you go for the example that I gave you, like the ceiling fan example. So in that particular example, like we are not having the possibility of like both the events to be equally likely, right? You may be having different probability. Both the events are having different chance of occurrence. Yeah, the ceiling fan may not be falling down. So under that one, I will define one term. Basically, how do we go for the probability? So you can just consider this particular thing. So just one statement that you can consider, probability of any event, probability of any event is just the relative frequency of the event in long run. Okay, that is considered to be a law of large number. So under this particular theorem, what I'm trying to say, if you calculate the relative frequency, and if you go for calculating the relative frequency in long run, like when you repeat the experiment again and again, again and again, again and again, and in long run, if you try to find the relative frequency of the event, then that will give you the probability of that particular event. Okay, I hope that makes sense in the most basic term. Okay, so you may be having like different type of probabilities. If you consider any standard book, this is going to be a course on stochastic process, so I will not go for very basic things. I will go for the things that are required for this particular course. So moving ahead, I will define the most advanced probability that we have in here, that is the axiomatic probability. So what's axiomatic probability? You must be having some idea. Like how do we define a particular like axioms, like what kind of axioms or some rules that the probability function may be following. So technically, if you say P is my probability function, so the if P is the probability function, then it must be holding or it must be satisfying some of the axioms. So the first axiom says that probability of any event must be greater than equal to 0. That means to say probability can't be negative. Okay. The second thing, if you just say probability of the entire sample space, that must be coming out to be 1. So the total probability must be 1. The third rule that we have to consider is if A1, A2, and so on, An are some events. Okay. So if these events are there, so if you go for like probability of their union, maybe. So if you go for probability of A1, union A2, and so on An, what will be this probability? That will be simply summation probability of I running from 1 to n, given that the event A1, A2, and so on An, they must be like disjoint. So if these events are disjoint, then their union probability, that will be just a summation of their individual probabilities. Okay. That are like some of the axioms that we have to consider in the axiomatic probability. Okay. So for the basic probability rules, that is enough. Now let's understand few terms that are required in the probability. So there is something that is known as a complement. So that is the complement event. So what does complement event mean to say? So if you are having some event A, then a complement mean to say not A. And the rule says that probability of event A, that must be coming out to be probability of a complement. No, that will be probability of A plus probability of a complement, that will be 1. Okay. So focus on whatever we are trying to cover. So the thing is, the two events, like if I just go for this thing, this can be a possibility, right? Probability of A, probability of not A, that can be same. Like probability getting ahead, that is half. Probability of not getting ahead, that is also half. So this can be like one particular case. But the standard result that follows, that is something like this. A can be like passing some exam, A complement is not passing the exam. So if you have read like properly, then there is a high chance that you may be passing the exam, right? So that kind of thing can be there. Well, that is the complementary event. Now we understand something about union. So union mean to say or. If they say A union B, that mean to say A or B. If they say intersection, that is your and this will be A intersection B. That basically mean to say A and B. So in this one, both the events must be occurring. That is the intersection part, like something that is common in both the events. Okay, moving ahead, if you go for the standard result, probability of A union B, that will be simply probability of A plus probability of B minus probability of A intersection B. Okay, this is the rule that we have to consider. Okay, these are very basic things. So whoever is taking up this course, he may be feeling that we are covering very basic things. Now let's move slightly ahead. So I define, okay, before moving ahead, I will define two more terms. There are some events that are known as exhaustive or exclusive events. So what are exclusive events? So events that are having nothing in common. So events that have nothing in common. So those type of events are known as your the events that are having nothing in common, those are exclusive events. So that means to say, if you say A intersection B, that will be coming out to be the null set. So in this case, probability of A intersection B, that will be simply 0, because though they are not occurring like simultaneously. Moving ahead, we have something that is known as exhaustive events. So what are exhaustive events? So events that take up the entire sample space. So events that take up the entire sample space. So that means to say, if you just say some event A1, A2, and so on AN, if they are taking up the entire sample space, so probability of A1 union A2 and so on, oh, okay, so on AN, that will be coming out to be probability of the sample space, and that is just the 1. Okay, we have to understand this thing. Now let's move ahead and try to understand few more concepts like that are like the slightly on the higher end. Again, basic, but slightly on the higher end. So we have to understand something about conditional probability. Okay, so what's the conditional probability? So if they simply ask you, you have to calculate probability of some event A given that event B has already occurred. So that is the conditional probability. Like we are putting up some condition on the event A, that event B has already occurred. Now you tell me what is the probability of event A. So in that part, this formula that will just extend to be something like this: probability of A and B over probability of B. And the condition that probability of B not equal to 0. And in fact, this condition, if you think in the very basic term, like without thinking a lot, then the idea says that, okay, this is something that is in the denominator. And the thing that is in the denominator, that can't be 0 in mathematics. But the fact is, this is not the reasoning behind the probability of B not equal to 0. The actual reason is that when you're putting up the conditional probability, so we have set up something that you have to find the probability of event A given that event B has already occurred. So if event B has already occurred, that means to say it is a possible event, right? So for a possible event, probability can't be 0. And being a probability function, it can't be negative. So it is something that is greater than 0. Okay, so that's what we are getting. That is the conditional probability. Now under this one, we have to understand the independent events also. So what are independent events? Like if you just say event A is independent of the event B, that means to say event A is having no effect of the event B. So simply probability of event A given B, that is coming out to be probability of A only. So mathematically, we are going to get probability of A intersection B over probability of B, that is coming out to be probability of A. So this gives you probability of A and B equal to probability of A into probability of B. You have to remember this one. Okay, this will be like again and again used. So technically what we are getting, so just remember, for independent events, the joint distribution, or you can say probability distribution, is just the product of marginal probability distributions. Okay, that is the thing. So if we are writing probability of A, so that is a probability that is allocating the probability of only single event A. So that is a marginal probability. But on the left-hand side, you are counting the probability of A and B, both the events. So that is some sort of like joint probability. Okay, that is the idea. Well, move ahead. So that is the conditional probability. Now, if I go for the next thing. Okay, so just consider this one case. If you have to see probability of A and B, what does that mean? What is the meaning of like simultaneous occurrence of two events? Is it possible to have two events occurring simultaneously? Any thought? Yeah. So if you go for that thought, then just assume maybe one case that you are having bread and milk simultaneously. Like generally we say that in the breakfast I had bread and milk. So what does that particular bread and milk mean to say? Like being a decent guy, I may not be eating like bread and milk like using my both the hands, right? So I may be having to decide something that first I can have a sip of milk, then I can have a like bite of bread. One possibility. The other pathway is I may be taking a bite of the bread first, then I may be going for the milk. So in this one, if you focus on, then there are only two possibilities. So either you can go and take event A first, then you go for event B, given that event A has already occurred. Or you can have the event B first, then you can go for the A, given that B has already occurred. Simultaneous occurrence, just put up the probability. So that's how we deal with the joint probability. So probability of A and B. So that's how it can be calculated. So I will be writing some or in between. Simultaneously, you can't like have both of them. So either it in like in this first way, or it can be in the second way that we just wrote. Okay, so this is also a nice concept that you have to remember. Okay, moving ahead with this thing. So there is something that is known as total probability theorem. So what's total probability theorem? So it is something like this, that some event A that may be occurring with the different events. So let me give an example and it will be more easy to understand. So if we go for the example, let's say in a particular university, students may be using different laptops. Okay. So if I'm saying that 60% of the students, they are using Windows laptop. Okay. And we are having maybe 30% students who are using Apple laptop. So maybe they are using the Mac. And we are left with 10%. So let's say they are using the Linux. Now assume that there is some new virus that is like hitting up the different softwares or something. And it is given that 3% of the Windows laptop, they get the virus. Okay. And maybe 2% of Mac, they are getting the virus. And if you finally go for Linux, maybe 1% of the Linux, they are getting the virus. So you can see this is some sort of like stepwise probability, some tree diagram. Yeah, that kind of thing. So the idea is in this one, they will finally say you find the probability that you are getting a virus. So you can simply see in this one to find the final probability of virus. So getting a virus, you first be having the laptop. You can have a Windows laptop, a Mac or a Linux. So first choice will be you will be going for the Mac. So if we have to calculate this, if we simply expand this one, then maybe you are at this location. Okay, you pick out a laptop. So you can have three choices. You may be getting Windows, you may be getting Mac, or you may be getting Linux. And you are given the probabilities 60, 30, and 10. So 0 0.6, 0 0.3, 0 0.1. Okay. Now they are saying that there may be a virus in the Windows. So there can be virus given that you are in the Windows. Okay, I will ignore the second one. Simply go for this one. There can be a virus given that you are in the Mac. There is a virus given that you are in the Linux. What is the probability? 3, 2, and 1. That is 0 0.03. That is 0 0.02. That is 0 0.01. Okay, fair enough. The simple, decent example. So at the end, you may be finding the virus in this manner, or you may be finding the virus in this manner, or you may be finding the virus in this particular manner. So we have only these three possibilities, three different pathway, and they are like not attached to each other, right? So mutually exclusive, you can say. So in this particular setup, if you have to find the probability of virus, then that will be simply probability of Windows into probability of virus given that you are in the Windows, the first case, or you may be picking up the Mac, you may be finding the virus given that you're in the Mac, or you may be going for the Linux and you may be finding the virus given that you're in the Linux. So that is the total probability theorem. Okay, got it. So we also already covered this thing. What is this particular thing? So that is nothing. That is probability of Windows and virus. This is probability of Mac and virus. This is the probability of Linux and virus. Got it? So that's how we can just relate to the total probability theorem. Now, if I go for the general form or the definition, then you can think about this case. So the general definition or general form of the total probability theorem. So let's say you are having this complete sample space. There are some events, let's say A1, A2, A3, A4, or it can be anything. So let's say we are having these number of events. So maybe some A1, some A2, some A3, and so on, let's say some AN. Okay, this is my sample space. Now, if I define the setup that goes something like this, that these events A1, A2, and so on AN are the partition of sample space. So what is the meaning of partition? So technically the events that are mutually exclusive plus exhaustive, those are known as partition. So simply exclusive plus exhaustive. Those type of events are known as partition of the sample space. So we got a partition. Okay. Now someone defined that there is some event that can occur anywhere in this particular zone. So let's say this is the event A. So now the probability of the event A, that will be nothing, that can be written as summation. So A can occur along with A1, A can occur with A2, A can occur with A3, and so on. A can occur with AN. So wherever it is not happening, that part will be 0. No worries. So I can go for I running from 1 to N, probability of A intersection AI. Make sense? And from the expansion formula, you can simply write this to be I running from 1 to N, probability of AI into probability of A given AI. So that's the total probability theorem. Okay. So just remember this. This will be required many times. Okay. In like any statistical course, you'll be using the total probability theorem. Well, now in the probability, the last discussion that we have to cover is something about Bayes theorem. So what's Bayes theorem? Okay. So in my terms, if I simply say Bayes theorem is some sort of like a reverse probability. So it is some sort of reverse probability. What does that mean? So if I go back to my same example, the Windows laptop, Mac laptop, and so on, and you may be getting the virus. Now it is something like, okay, to the frame, we know if we are at this location, we first have to pick a laptop. Then you will be finding the virus that you are in the laptop or you are using the laptop. That is the format. Now, in the Bayes theorem, they will say that, okay, you got the virus. Now you tell me which laptop you are picking up. So you can see, like to the point, we have to pick the laptop first. But in the reverse probability, in the Bayes theorem, they are moving back. So that kind of thing. So if we try to understand this concept, so simply have a look on this thing. Let's consider that you have to go for probability of maybe Mac, given that you got the virus. We have the probability formula that is simply probability of Mac and virus over probability of virus, correct? The conditional probability of A given B. I'm just writing that thing. Now, if you see the numerator part, that is like a joint probability, and I just explained you that there is nothing like joint probability. Like two events, they are not occurring simultaneously. You have to define in the terms of conditional probability. So if we turn up in the conditional probability, then if you just simply focus which event, getting a Mac or virus, which event occur first? Getting a Mac, obviously. So in that part, probability of Mac into probability of virus, given that you are in the Mac, over total probability of virus. And total probability of virus, that we already know. We just covered in the last form. So that is probability of Mac into probability of virus given Mac. over total probability. So three different cases: probability of Windows into probability of virus given Windows, probability of Mac into probability of Mac given Windows, virus given Mac, plus probability of Linux into probability of virus given Linux. Yeah, so that is the reverse probability. Moving back. Well, if I go for the general form, so in this one, they will simply ask what is the probability of getting maybe the AI event given that event A has already occurred on the same setup. So that will be simply probability of AI into probability of A given that particular AI over probability of A. Okay, so that basically mean to say we are going to get probability of AI into probability of A given AI, denominator summation I running from 1 to n, probability of AI into probability of A given AI. So that's the Bayes theorem. Okay, so this was all about the basic introduction about probability, a review of the probability. I hope you're able to understand. See you in the next lecture. Bye. Thank you.